All right, example 2, the flash unit on a camera operates by storing charge on a capacitor and releasing it suddenly when the flash is set off. The data describe the charge Q remaining in the capacitor measured in microcoulombs at a time measured in seconds after the flash goes off. Use the data to draw the graph of this function and estimate the slope of the tangent line at the point where t equals 0.04. This is the same skill we did on Friday. The only difference is on Friday we had the capacity, since we had a function, to get really close to our point of tangency. Where here we have just a chart of values. So we're limited within the extent of this chart to get as close as we can. It's going to cause our answer to be much more approximated and much less accurate. All right? Basically, you do the best you can do with the chart you're given. All right? If you have a function, you have the ability to get right up on it, 0.9, 0.99, 0.999, and so on. In this case, it would be 0.039999 and 0.040001. But I don't have those numbers on there, right? So I can't, the closest I can get to 0.04 from the one side is 0.02. Closest I can get to 0.04 from the other side is 0.06. These 2 points will give me the best approximation, but you'll see they're way off. They're not nearly the same. All right, so there's no way to really guess as to what the answer is based on just those numbers. We're going to have to do a little bit of extra stuff. All right. In general, 0.1 second, that's not very much time. If you ever get a stopwatch and go boom boom like that, that's like usually like 0.18 or something like that. So that's that's probably double the amount of time we're dealing with here. So we're dealing with almost no time here. So if you've ever seen a flash and the camera go off, it just flashes light like that, you know, really fast. This is the amount of charge left on the capacitor each 200ths of a second after the flash goes off. So it's dropping pretty dramatically. After 0.1 second, it's only got about 36% of its charge left. All right. So basically, you just have to understand what the chart represents. So T is time in seconds. Q is the amount of charge left in microcoulombs. I don't know what a microcoulomb is. We don't have to know what a microcoulomb is. It's some unit of energy. Okay, but just know that we started off with a full charge and it decreased after the flash went off. All right, so let's see what happens here. First thing they asked me to do, I think, is there a list of things to do, or are we just doing it? It doesn't ask us to do anything. Well, I'm going to do some of the stuff they asked you to do in the homework on this problem. All right. One thing they ask you to do is to graph the data. All right. Use a scale if you graph data. So you can see here I'm going by tens, and I split the graph here. So because nothing's happened between 0 and 30. See, numbers happen between 36 and 100. So nothing happens between 0 and 30. So I just chop that off. You can see the times, 0.02, 0.04, they're going up by 0.02, they're in a pattern, so I just made sure each of those was in there. Okay, so 0, 100 is up here. 0.02, 81.87 would be about almost 82. I'd call about there. 0.04 is 67.03. That'd probably be about here. 0.06, 54.88, almost 55, almost halfway. 44.93 is almost halfway. And 36.76 is probably about here. All right. I didn't get a ruler out, I just approximated positions. The 55 and 45 I put pretty close to the center. 37 and 67 I put a little bit above center. 82 I put just a little bit above the line, like so. Okay, just getting the points plotted. And I look at that and it looks like it has kind of a little shape to it, right? It kind of goes down and starts curving a little bit at the end. So I'm just going to make the graph itself fit that. Kind of challenging, but I'll do my best. It's easier for you guys because your shadow doesn't get in the way as you try and draw it. But there you go. So that's the graph, that's what it looks like. My point of tangency, which I'm going to slide this guy, oops. Move that to the back. Nope, that's too far back. There it is. asking my point of tangency. I'm going to make my point of tangency a different color too. Let's go red. All right, there you go. That red dot's my point of tangency. That's the point they care about, right? So going back to the problem that they gave us, they want the data to draw the graph of this function, estimate the slope of the tangent line where t is equal to 0.04. So let's talk about estimating the slope of the tangent line. So we all know what a tangent line looks like, right? The line touches the curve in one spot. So if I was to try and draw a tangent line here, and with you guys I would get a ruler. For me, I'm going to do my best, okay? But if you get a ruler and kind of line it up so it looks tangent, and then just slide it right on there. In fact, you know what? I have a ruler. Do that. There we go. That looks pretty tangent, doesn't it? All right. So if I, oops, grabbed the wrong thing. Move it off just a smidge there, okay? On a red pen and draw a line around the ruler. There's a tangent line. All right. Okay, so there's my tangent line. Now, here's the thing. If I continue this line down, which I think I can do. Oh. Suppose, let's just take this line up. Suppose I did that. Is this right here, which would be about let's go 0.108 comma 0. Is that a good point to use? I'm just asking before we start.
No.
Okay, why wouldn't that be a good point to use? 0.108 comma 0. I'm talking about right here.
Because it's not close to t.
Well, we have to pick a point on this line because this line's tangent, right? So I've got my point here, which is 0.04 comma 67.03. That's 0.1, right?
Yeah.
I've drawn this nice line here on my curve, right? That looks tangent. And this is another point on the curve, right? About 0.108 comma 0. And I'm asking, why is that a bad point to use? There is a reason. It's not too far away. There's an actual reason why 0.108 comma 0 is really, really bad to use.
Because it ain't on the chart. Yeah, the blue line won't hit it.
That doesn't have to even be on the chart. Points on this line, the only point on this line that's going to be on that chart is going to be this 0.04 comma 67.03. Every other point on the chart would be on this blue curve, not the red line. There's a reason. You guys are overthinking the reason, I think. What's this mean?
Oh, it's breaking the graph.
I chopped the graph, right? So this is actually 0.108 comma 0. It's actually probably 0.108 comma 20 if this is the same, right? So be careful if you do break the graph, which I do recommend quite often because a lot of times nothing happens for a while, and if you're not breaking the graph, you got this big empty space in your paper that's not doing anything except taking up space. So chopping the graph is helpful, but if you're going to be using points on a line to estimate slope, make sure you don't pick points beyond the break. All right? So for me, I would probably focus on this point over here. All right? When you're estimating the location of a point, estimate a value, not two values. Don't estimate, what I'm saying is don't pick this point here. Okay? Then I got to estimate where this is and where that is. That's two estimations. That causes me to be less accurate. If I pick this point right here, that's 0 comma what?
93.9.
93.9. All right? Okay. Is 93.9 exactly right? I have no earthly idea. It sounds good to me, though. It looks like it's less than 95. I would have gone with anything between 93 and 95 would have been fine with me for an approximation there. We're guessing. There's no way to be 100% accurate here. Your answer will not be the same as your friend's answer. Okay? The point is, though, that you can draw a line that looks tangent and you can approximate its slope. That's one way of doing this problem. So, if we do that, applying the slope formula, this is the point of tangency. This is a point on the line of tangency, right? So this point and this point both lie on the red line, which looks to me, with my eyes, that it looks like it's a tangent line. And if I have 2 points, I find slope by doing y minus y over x minus x, right? So if we do that, 93.9 minus 67.03 divided by 0 minus 0.04. And then my calculator knows the answer to that. Make sure when you type it in your calculator that parentheses go around this and parentheses go around that. If you just type the whole thing in. 93.9 minus 67.03 divided by 0 minus 0.04 comes out to negative 671.75 micro columns. What's the, it's like MB or something like that. Per second. Okay, that is a way to approximate slope. You graph the data, you approximate a tangent line using a ruler and a straight edge, or a ruler or a straight edge, all right? But just lay it down, draw a straight line, approximate the value of a point that's on the straight line. You got your point of tangency, do a slope formula just like algebra 1, algebra 2. Y minus y over x minus x is slope. Now, the way we would have done it in calculus is we would have picked values closer and closer and closer, right? So if we consider, take a look at this line right here. Let me get my ruler out again. Suppose I connected this dot and that dot. Let's see if I can make that happen. That's pretty good. All right, so those two dots right there, this dot and that dot, dots that I have actual specific data for. Okay, if I draw that line, let's take a look at it. That's not going to be the tangent, is it? Because it's curved twice. All right. But notice that it's close. It's close to the tangent, right? So I could very easily find the slope of that. How would I find the slope of this green line?
Same thing you did for the red line?
Same thing I did for the red line, except I'd use exactly these 2 points here, right? Instead of having to approximate some point in there, I would just use the data in my chart. If I found the slope between these two lines, these 2 points, I get a secant line, but it's really, really close to the tangent line. Same deal as if I found the slope for this point and that point. If I connect those two dots, let's try that. It's much easier to do on paper with a ruler, but that looks pretty good. All right. Let's make this one purple. People like purple. All right. So looking at this purple line here, another secant line, right? And if I did the purple line, I'd be using this point and this point, right? All right, notice the purple line and the green line, where's the red line at in relation to those two lines? Kind of in the middle, right? So another technique we could use if we're given a chart of data, find a secant slope, find a second secant slope, average those two slopes, and you're going to get close to what the tangent slope is.
Oh.
It's not perfect. Again, there's no perfection here because we don't have enough data. We don't have an equation that allows us to get zeroed in on the right answer, right? All we can do is approximate. The answer should be rather close to this, though, and if we try it out, which we will, let's do first of all the secant from 0.02 to 0.04, and that's going to be 81.87 minus 67.03 divided by 0.02 minus 0.04. Type that in our calculator to save time. My calculator says it comes out to negative 742, which is nowhere near negative 671, right? But again, it doesn't have to be. Why is it such a large discrepancy, do you think?
You ain't even close enough.
Well, they look almost the same though, don't they? That's like 29, 61 away from each other, 60 to 61 away from each other. Why such a large discrepancy, do you think? This is so tiny compared to that. So little tiny differences there make large differences in the overall value. All right, that's why. The change in y, big scale, over change in x, small scale, creates large discrepancies. Okay, so sometimes scaling graphs, they look really close, but they aren't. All right, keep that in mind. So, and again, it's fine. We're not going to get, again, we're not looking for perfection. We're just looking for information. This is obviously the wrong answer, and it's too steep. We need something less steep. Purple's less steep, right? All right, so if we do the purple one, we're dealing with these 2 points. I'll do 67.03 minus 54.88 over 0.04 minus 0.06. Type that in my calculator once again for the sake of saving time. Comes out to negative 607.05. Purple just changed colors all of a sudden. Okay, once again, these are micro columns per second. So this is too steep, this isn't steep enough, but if we average these two values, the one that's too steep, the one that's not steep enough, since the red line is kind of halfway, but sort of kind of halfway between those, if I average these two, I should get pretty close to the same answer. So if I add these two things up and divide by 2, so negative 742 plus negative 607.5 divided by 2, because that's just basic averaging. Negative 742 minus 607.5 divided by 2, negative 674.75. Okay, micro columns per second. Okay, look at the answers. They're almost the same. And again, this answer, Chris gave us 93.9. I don't know if Chris is right. I have no idea. All right, it could have been 94, it could have been 93.5. I don't know. All right. The point is, though, that we're approximating things. We're going to get the best answer we can with the data we have. That's all you can do. Okay, the 3 problems for tonight's homework are going to have a chart given to you. They're going to give you specific directions. Anytime they say find the slope of a secant line, they're telling you to pick 2 points on the curve. Okay, they're going to identify a point of tangency. In this specific case, the point of tangency was this one, right? That's always going to be considered point P. All the other points are going to be point Q's. So when they find the slope of a secant line, PQ, where P is the point of tangency and Q is some other point on the curve, here's a Q, here's a Q, here's a Q, here's a Q, here's a Q.
Pick one.
Pick the one they tell you to pick. Sometimes they tell you to pick all of them. Find all the slopes. The 2 that matter the most, though, the 2 that are the best, are the 2 that are closest to P. Okay, if I was doing it myself, if they told me to find all of them, the only 2 I don't really care about are these 2. And I would average those 2 to get myself an approximate slope. If they ask you to graph it and draw a tangent line in to approximate, the point of tangency itself is one point. Some point you estimate is another point. Point on the line, not on the curve. Okay, you draw what you think is the line of tangency. Okay, and then the point of tangency itself has to be a point on the line, right? The other point, some other point. I could have picked this point here. That might have been better to pick 0.02, 80. That looks like it's dead on it, right? That might have been a better point to pick. I would have gotten probably almost the same answer, honestly. Okay, the slope of that line is what it is. But again, you're approximating things, so it won't be exactly the same probably. All right? Don't look in the back of the book and say, oh, their answer is this, my answer is this, so I don't know what I'm doing. Okay, you're going to be close. You might not be exactly the same. If you're exactly the same, it's a coincidence.
Trust ourselves, right?
Yeah, do what you're supposed to do. You're using the slope formula, y minus y over x minus x, Algebra 1 level stuff here, all right? The difficulty is understanding what it is you're finding, all right? So again, you're finding some secant slopes and averaging those to get an approximate tangent slope, or you're drawing a tangent and approximating the slope of the tangent line by approximating points on the tangent line. Then just apply the Algebra 1 slope formula. Record your results, move on to the next problem. If they ask for the equation of a tangent line, then use the point of tangency as the point along with the approximate slope you found to find the equation of that line. All right? Don't overthink it. They ask you to graph it to the best of your ability. Scale as you see necessary. They get huge numbers, go up by tens or hundreds or whatever. They get really, really tiny numbers, go up by 0.01, 0.1, whatever. But scale as you see necessary. Break the graph if there's nothing happening for a while. I want 0, 0 to be there. All right? So that's all I need.